Hello and welcome to Algebra 2, Chapter 6.8, Analyzing Graphs of Polynomials. So we're going to kind of put together everything we learned about the graph of a polynomial. So first of all, a little concept summary. So if we have a polynomial, then the following statements are equivalent, meaning the following statements mean the same thing. So the first thing is that we're going to talk about a zero. And if k is a zero of a polynomial function, so all the zeros we call k's. So if we have a zero, then we also have a factor. And remember, if x equals k, we subtract k to the other side, and then we get our factor. So if we have a zero, then we have a factor, which also means we have a solution because our solutions are our zeros. And then that means we know what the x-intercepts are because our x-intercepts are our solutions. So really the first one and the last two here, they all mean the same thing. And so if we have a zero, we have all of these things. Or if we have a factor, we have all of these things. So we can use this to help us graph. So the deal with graphing is if it comes to you really in factored form, then you know your zeros. Okay, so each factor, and there's three of them here, are going to be set equal to 0. That's your zero product property. Now -2 equal to 0, you can toss that one out because it doesn't do us any good. X squared minus 9 equals 0. If you solve this using your square root property, x is going to equal plus or minus 3. So there's two zeros. And then our other 0 is x equals -4. So some steps here. Step number 1, plot your x-intercepts. Okay, plot your x-intercepts. So I'm going to put a point at -4, a point at -3, yep, and then a point at +3. Okay, so there's my x-intercepts. There's 3 points on my graph. Step number 2, we're going to plot additional points. So for this, you're going to use a table. So we have x and we have y. I would do -5. I would do -3.5. Then I might do 0. We'll see where that takes us. So I'm going to use my calculator to type these in. So give me 1 second here. And you could definitely be typing these in as well. Make sure that we get the same answers. Alright, so for -5, I get 32. Okay, so there's no real way I'm going to graph that one, but we're going to leave it there. Okay, so let me do -3.5. I get -3.25. So somewhere down here. Okay, so we know what's happening between those 2 points. So if I go to 0, at 0 it's at 72. Probably not graphing that one either. Okay, so what is it? Let's try, I want to see about 1. Oh, but 1 it's at 80. At 2 it's at 60. Okay. So here's what it's happening. It's jumping, it's coming here, going way up here. Then we're coming here and going way up here and coming back. It's not a great graph of it, but that gets us a roundabout view of what that's going to look like. Okay. You might also look at your end behavior. So maybe if we were going to add a step 3, I would say look at end behavior. If you were to multiply all of this out, you get an x cubed, which is going to have an odd degree, and you'd get a leading coefficient of -2. And so if you refer back, then you could look up, page 331. So leading coefficient is negative, degree is odd. It says that our function approaches positive infinity as x approaches negative infinity. And it does. There's approaching positive infinity. And our function approaches negative infinity as x approaches positive infinity. So putting that all together, then I know that we've graphed it correctly. All right, so then let's look at this one. So again, it's in factored form, which, it's nice if it comes in factored form, but this is also something that you could do now, is factor these. All right, so if we set all of our factors equal to 0, x equals 0 is one of our zeros. 2x minus 5 equals 0 is going to mean x equals 5 halves. And x plus 5 equals 0 is going to mean x equals -5. So there's my 3 zeros. Okay, so step number 1, plot those. So 0, 2.5, and -5. Okay. Step number 2, find some additional points. So let's do -6, -4, -1, 1, 2, and 4. Let's do that. Again, I'm going to plug it into my calculator. For -6, I get -102. For -4, I get +52. For -1, I get 28. +1, I get -18. +2, I get -14. And +4, I get 108. Okay. So maybe a little better than we did last time. Let's count by tens. So when you get all the way up here, that's actually going to be 100. This down here is going to be -100. Yep. All right. So then I can actually plot -6, -102 is down here. -452. It's going to be about there. -128. Maybe about there. 1, -18. 2, -14. And 4, 108. So if we connect the dots, we're looking at something like that. Okay. And then if we do check it with our end behavior again, if we multiply these together, we're going to have an x cubed. This time though, we're going to have an even or a positive leading coefficient because you're going to get 2x cubed. And it does say then that f of x approaches -infinity as x approaches -infinity, and f of x approaches +infinity as x approaches +infinity. So turning points, we've mentioned these a few times, but turning points are a characteristic that corresponds to a local minimum or local maximum. And you can have multiple minimums and maximums. It's just in that region that's the local minimum or maximum. The y-coordinate of the turning point is the local maximum or minimum if the value is higher or lower than all the nearby points. So we're looking at the y value, okay? And so, if you have something that's, let's say it looks like this. There's a minimum or maximum, minimum, maximum, minimum, maximum, minimum. The deal is just on all its surrounding points, if that y value is greater or less than the surrounding points, it's a local minimum or maximum. So we have something that's going to tell us about turning points. And it says a polynomial function of degree n has at most n minus 1 turning points. So if you have degree 3, you have at most 2 turning points. If you have degree 10, you have at most 9 turning points. And if a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. Okay? So if we're looking at something, let's say, that has 4 zeros, so let's say there's 0, there's 0, there's a 0, there's a 0. For me to get to all those zeros, I had to have 1, 2, 3 turning points, which is n minus 1 turning points. So we're going to graph this function, and we're going to identify the x-intercepts, the local maximums, and the local minimums. Now, to do this, unless it has just really nice integer answers, you're really going to need to use a graphing calculator. So, next time in class, we will go over how to use the graphing calculator, if you don't already know, to find the x-intercepts, your maximums, and your minimums. Like I said previously, if you don't own a graphing calculator but you have a smartphone, you might also want to have downloaded a graphing calculator app that will help you do that. So that is all I have for today. Have a great day, and I will see you next time.